So here we are, and I'm wondering if you figured it out. So we've got lots of right triangles going on here, but what's interesting is that we've got our inscribed circle, and because it's inscribed in a triangle, that's going to make each one of these angles 360. They're going to each be congruent. 360 divided by 3 is going to be a 120-degree turn. So it's symmetrical when you've got that inscribed circle inside a polygon. So if a circle was inscribed in a quadrilateral, you would divide it by 4 to get the congruent number of angles inside, that turn between tangencies. So the rotation from one point of tangency to the next. Because that's 120 degrees, and we're going to create, I'm not sure if you saw that when the video first started, but we're going to create these congruent triangles, right? And we could prove that those two triangles are congruent. That's going to make this angle cut in half. So let me draw it here. So I've got this right here, and this is a 60-degree angle right here. This side is 4, right? We need to know the radius. So that length is the radius, and that's all we need. That is all we need, because the radius is the short leg. So the radius is across from the 30-degree angle, it's the short leg, and 4 is the long leg. So 4 is going to be r times the square root of 3 is equal to 4. Because you take your short leg, which is r, so that's your short leg, times the square root of 3 equals the long leg, and the long leg is 4. So to solve for r, we're going to divide by the square root of 3, and then we need to rationalize. So the radius is 4 times the square root of 3 over 3. So the radius is equal to 4 times the square root of 3 over 3. So yes, we did have to do quite a bit of work to figure out the value of that radius, but you have to admit, it really put so many things that we've learned together. And if you were able to follow that, then you're following along with everything that we've done for, I don't know, the past 3-4 months. So that's awesome. That is absolutely awesome.